Good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before this tutorial is Hamper Clement. So if you are new to this channel, consider subscribing and also hitting the like button, and also don't forget to share. So today I will be doing integration, particularly inverse integrals. So let's get started. How do you go about a question that is requiring you to find the integral of tan inverse of x dx? Well, this is very simple. The concept that we use is simply Lie, where L is for logs, I for inverse, A for algebra, T for trigonometric functions, and E for exponential. Now, for this particular question, tan inverse of x is an inverse function. Dx is an algebraic function. So inverse comes first, then algebra. Therefore, I'm going to name this particular expression as my u and this part as my v. So notice that u is going to equal to tan inverse of x. Du will equal to, so dy dx of tan inverse of x is simply 1 over 1 plus x to the power 2 dx. dv is simply dx, and of course if we find the integral of this, we are going to find v equal to x. Alright, so from here we now get to our formula. Notice that the integral of u dv is equal to uv minus the integral of v du. What is u? Our u is simply tan x, tan inverse of x. Our v is x minus the integral of v, which happens to be x. Notice that du is 1 over 1 plus x to the power 2 dx. So from here we can use we can multiply, so that can also be written as, this is tan inverse of x, this is x minus the integral of x over 1 plus x power 2 dx. From here, notice that I can set this equal to u. So I'll say that u will equal to, that is the u substitution, 1 plus x power 2. Notice how my du becomes 2x dx. So I want to make dx the subject, so I'll say over 2x over 2x, and of course my dx is equal to du over dx. Sorry, this is supposed to be 2. So having done that, that makes even much more sense, because from here, because from here we have, this is dx, that will be equal to du over 2x. I can do my replacement. So if I do my replacement, I'm going to have tan. This is going to be my tan inverse of x, and of course my x here minus my x over, okay, this is supposed to be 2x u du. Okay, so I just replace this particular expression. So now this x and that x can cancel, and we're going to have my tan inverse of x minus, this is going to be 1. Remember, this x and that will cancel, so this will be 1 over 2, the integral of 1 over u du. Okay, so this is just the same as, this is tan inverse of x, this is x minus 1 over 2, the natural log, because we know that integral of 1 over u is natural log of u plus some constant c. So my final answer will be written in this way. Okay, so this is my x. My final answer is going to be 1 over 2, the natural log of, I replace where u is with this expression. Okay, so I'm going to have, this is 1 plus x power 2 integral of closed absolute value, that is plus some constant c. So this is just how you answer this particular question. Okay, it's very simple. Let's try another example. How about if you have been given how about if you are dealing with a sine? How do you do it? All right, so how about if you have the integral of sine inverse of x dx? Notice that inverse comes first, so in this case this part becomes my u, this part becomes my v. Okay, so we say u is going to equal to sine inverse of x. Notice that du is equal to 1 over square root of 1 minus x power 2. Okay, 1 minus x to the power 2. And this makes sense, of course. And this makes sense. Okay, so now we establish our v. Okay, so of course I like writing it as dv is equal to dx. If I integrate this, my v is going to remain as x. So from here, I'll use my formula. U dv is going to equal to uv minus integral of v du. What is u? U is sine inverse of x. What is v? V is x minus, what is our v? Of course, we have x, and du is 1 over square root of 1 minus x power 2. When we reach here, we can multiply and not forgetting the x. We can multiply everything and we're going to get sine inverse of x minus integral of, this is supposed to be, okay, when we multiply this, I guess the x is supposed to come on top, so our x is going to come on top like that, and we have our 1 minus x power 2. From here we can use the u substitution. We can say let u equal to 1 minus x power 2, so that du can equal to negative 2x. And of course we have sine inverse of x, then x like that, minus, so this is going to be the integral of x over, of course this is supposed to be dx, so if we cancel out, we make dx the subject. Notice that dx is du over 2x. So of course we are going to have our negative 2x here, then we have our u and du. This guy and that guy will go. Notice that we're going to have negative 1 over 2. This negative and the negative are going to multiply, and we are going to remain with sine inverse of x, our x there, plus the integral of 1 over square root of u du. Okay, so let me just try to wrap that and create my space. Notice that root of u is the same as u 1 over 2. And if we integrate this, okay, so that means that 1 over root of u is the same as u power 1 over 2. So if you add 1 to the top, even there you add 1 to the top, you still get u power 1 over 2. Okay, so from here, this simply means that if we integrate this, we are going to get this. So this can also be written as sine inverse of x plus, okay, so this is just the same as u 1 over 2. So if we integrate this, this is going to remain in this form. Okay, it's going to remain in that form. So let's try to do that. So we have integral of, supposed to be u to the power negative 1 over 2. All right. So from here we have our, this is sine inverse of x plus, from here we are going to have something like, if we integrate that, that is going to remain as plus. Of course, remember we left our negative, so it's going to be, this is going to be 1 over 2, and of course that is going to be the integral of, that is going to remain as open bracket 1 over 2, like that. So that is just the same as sine inverse of x plus 1 over 2 like that, u plus c. Okay, so this is going to be sine inverse of x. Okay, so these are multiplying, then x is going to be plus 1 over 2. Inside, I'm going to put what I took from there. This is 1 minus x to the power 2 plus some constant c. So this is just how you solve this particular question. It's very simple. Let's try to solve cosine. Okay. How about if you have been given to calculate the integral of the integral of cosine inverse of x dx. I'm going to solve this one very quickly. So notice that this one is cosine and this is our dx, and of course this one becomes our u and our v, following the Lieti concept. Notice that u is equal to cosine inverse of x du is going to equal to negative 1 over root of 1 minus x power 2 dx. Notice that our v is equal to dx. Let me just call it dv, like I like doing it. So if I integrate this, my v is going to be x. From here, I can use my formula. V, actually it's supposed to be u dv. Notice that u dv is going to equal to uv plus minus integral of v to u. If I do my replacements, what is my u? My u, of course, is cosine inverse of x, and my v is going to be x minus the integral of v. V is x multiplied by, and of course, this negative 1. So, of course, we know that this is just a positive because of this negative, the negative that we have here. Meaning, I'll write it as a positive number. 1 minus x to the power 2. From here, notice how this is cosine x, then x plus, let me just write it as x over 1, then this minus x to the power 2. Not forgetting the dx always. I can use u substitution to make everything simple. U is going to equal whatever I have in the square root, and it will be 1 minus x to the power 2. Notice how du becomes negative 2x dx over negative 2x over negative 2x. And of course, my dx is du over negative 2x. So from here, I can do my replacements. Cosine inverse of x multiplied by x plus. So this is just the same as the integral of x over, this is negative 2x, then square root of u. That and that must go. And of course, I'll remain with this particular expression plus. Now remember that we have a negative there, so to deal with it, of course, we're supposed to multiply and just show it. So my negative is going to lie here. And of course, I have a 1 remaining there, so this will be 1 over 2 integral of 1 over square root of u. From here, if you remember on the previous question, to make that simple, notice that, let me just use another pen. Notice that integral of 1 over square root of u is the same as integral of u power negative 1 over 2. And if you add 1, like that, you're going to remain with just u power 1 over 2, which can also be written as u square root of u, just like that. So we shall use this particular concept even here. So this can also be written as, I'll just write it as a direct answer. Okay, so our final answer, of course, is going to be the cosine inverse of x, then x minus 1 over 2 square root of u plus c. So cosine inverse of x, x minus 1 over 2 root of, I can do my replacement. My u, of course, was 1 minus x power 2 plus some constant c. And this is just how you get to solve questions on inverse trigonometric functions, that is under integrals. If you enjoyed this video and this video is so helpful, consider subscribing. Thank you so much.